We'll finish our discussion on functions by first going over higher order functions. A higher order function typically is a function that takes in another function as an argument. Let's have a look at a very common higher order function, the filter. Back to Jupyter Notebooks, declare a list of numbers is equal to 1, 2, 3, 4, and 5. Alternatively, I could have used the range function to create this list, but regardless, what we want to do is filter out any number that's odd. With your current knowledge, you could use a for loop, iterate through this entire list, check if the number is odd with an if statement. If it is, remove it from the list based on the index. We did something very similar to this before when we modified lists based on for loops. But that would be a little tedious and not very concise. There is a much easier way, and that is to use the higher order function filter. What we'll do is we'll write filter to denote the filter function, and the first argument of this filter function is, guess what? Another function, which makes sense since we're dealing with a higher order function. More specifically, it takes in a function that returns a Boolean. So what filter will do is it will go through every single element of our list. For every element that it iterates through, it's going to pass it into our function. In our case, the function will evaluate whether or not the number that's being iterated through is even or odd. If the number is indeed even, the function will return a value that evaluates to true, telling the filter function, hey, we're going to keep this value. Otherwise, if the number that's being iterated through is odd, the function will return a value that evaluates to false, telling the filter function, filter out this number, get rid of it. Now that we went over the theory, let's execute it. We're going to make a function, def, even, or odd, which takes the number that's being iterated through. We're just going to call it number. That's the argument, and that function will return number modulus 2 is equal to 0. Make sure this is a double equal sign since we're declaring a comparison, such that we want to check if the number being iterated through, is it even or odd? If it is even, it will evaluate to true and it will tell the filter function to keep the number in the list. Otherwise, it will evaluate to false, and the filter function will know to remove the number. Obviously, the next step is to actually invoke this function inside of filter, even or odd. And careful, do not specify a parameter inside of the filter function. The second argument of the filter is the iterable that we want to filter from. In our case, the list, the numbers. Finally, we just have to convert this back to a list by enclosing it with a list type. And if we print this, run the code, it outputs 2 and 4. It removed all of the odd numbers. It iterated through every number in our list, and for every iteration, it checked to see if that number divided by 2 does it give a remainder of 0. Is it even or is it odd? If it was odd, if the remainder was not 0, the function returns false and the number is thereby filtered out. And we get our even numbers. There's one problem with this. Remember what we talked about earlier. Functions should be reusable chunks of code. If you're just going to use it as an argument in a higher order function, it's not really reusable. That's why in this case we use the lambda operator. The lambda operator provides a way to create small anonymous functions, functions without a name. They are helpful for creating quick functions that aren't needed later in your code. How do we create a lambda operator? Well, first we need the lambda keyword, lambda. We need the lambda keyword to indicate that this is a lambda expression. Following lambda is the argument that's passed in from the higher order function. In this case, we'll just call it number. Similar to functions as well, following that is a colon. And finally, what comes next is the expression that's being evaluated and returned. In this case, we're returning a Boolean expression that checks whether or not the number being passed in from the filter function, is it even or odd? If it is even, it evaluates to true, otherwise false. So just copy and paste that, and we should be good to go. Notice how we don't need to specify a return value inside of a Lambda expression. This is much more concise. If we delete this, run our code, we get the exact same results. This acts the same way as our regular function did. There are obviously a lot of higher order functions in Python, like map and reduce. We're not going to discuss all of them. You will come across them later on in the course, but for now, I just want you to keep in mind that although Lambda expressions are not ideal to replace complex functions, they can be useful for short, simple functions, like the one we just saw in this lesson.